Most of the questions in the next hour are going to be difficult, but they're not politically difficult, or at least I hope they're not politically difficult. Some of you may know I practice patent law. My training is as an environmental chemist. So I came to political science, international relations, the study of terrorism through a very circuitous route. But it's a route that I think was something that allowed me to question all of the conventional wisdom, because my training is, as was alluded to earlier, a science training. And a science training, first and foremost, says, is there evidence, and can we test this idea? And is it then useful as a predictive tool? And my own bias about the social sciences is that they're not sciences because they don't pass that test, right? Because the evidence is often contradictory, and it's either impossible or at least it's immoral to hold one of the variables constant because you're dealing with human populations. So how do you starve out a bunch of people to verify your theory that malnutrition really does affect the polity? You can't do that. Secondly, you can't actually look at the theory and say, does this allow me to predict something? Because the predictive power of our theories, even our best theories about international relations, about economics, is so frightfully small that for a scientist it gets lost in the noise. Right? Scientists work at the 95% confidence level or get laughed out of town. In many fields, we now work at the 99% confidence level or higher. We're dealing with things in the social sciences where correlation coefficients of 0.55 are considered to be really important. And you ask any scientist and he will tell you correlation is not causation. In the social sciences, that's blasphemy because we can't ask the causation questions. So I wanted to understand something about human nature, something that was universal. And in working on the issue of terrorism over at FPRI after 9/11, started talking to elected officials, military officers, and policymakers about concepts of innovation and why terrorists seemed to be always 3 steps ahead of our military. And what I found was that those people to whom I was speaking had no clue what innovation was. None. Now, you can hardly expect them to, because innovation has never been a part of any of the disciplines from which they typically originate. There's no such thing as innovation studies in the fields of political science, sociology. It's just not part of the discipline. Law is counter-innovative, right? Law is supposed to be governed by precedent. Innovation is a dirty word in law. Creates a lot of our problems today. As a patent lawyer, I'll tell you that at length. Just ask. And so I started thinking about how would you educate these people about the fundamental importance and nature of education, of innovation in education. And then I started looking at the literature, and in the literature, the same stupid question occurred again and again and again. And the question was, what's the most important invention in human history? Back in 2000, the History Channel actually produced a 3-evening special on this. They went to the world's greatest experts and they got their consensus, and they did it as a countdown. So they held you in suspense all the way to the last 3 minutes of the last hour on the 3rd night. And they're asking all these people, what's the most important invention in history? And of course, the answer comes based on your field of experience and endeavor. So for some people, it was gunpowder. Right? For some people, it was the printing press. For some people, it was the oral female contraceptive. Just depends on where you come from. And I decided that was a dumb question. It was a dumb question because it didn't ask people to actually think about the issue. It just depended on what you knew, what you could pull out of your experience. So I started annoying people. And I annoyed people by asking them the following question. What are the 25 most important innovations in all of human history in rank order? Now, most people responded by telling me that their heads hurt. But a lot of people tried. And this is the result of that. And what I'm about to walk you through is a living document. Because every time I do this presentation, I get my eyes opened by people who hear it, who have really good and original thoughts about where I'm wrong. And that I have a lot of fun with. So this whole approach is something that you don't necessarily need to teach to your students, but it is something that your students can use as what Dawkins refers to as an intellectual crane. It's one of those fundamental things upon which we can erect knowledge. And so that's what Stone to Silicon is all about. And we start by getting, as we always do, a shared understanding of our terms. So, what's innovation? And the innovation definition here is mine. You're welcome to your own. But this one seems to encompass both senses of the term. So innovation is a process. So that's the active verb. And it's a process of making changes by introducing valuable new methods, ideas, and products. Focus on the word valuable. Because there are lots of things in the world that are new and that are changes, but that ultimately don't have any value. Now, the other part of innovation is that an innovation is the thing itself. It's the thing that's created that's new that has value. So noun and verb. Right? It's a dessert topping and a floor wax. The important distinction here is that innovations are not just what we learned in elementary school. It's not just tools and toys. It's not just inventions. But also innovations encompass our theories, our systems of belief, the way that we organize groups of people, processes, discoveries, all innovations, because if it's a value creation mechanism and it's new, it falls within my definition. So, why? Why is this important? Well, it's important because, as your students will love it when you say this, humans are universally lazy and we love to cheat. How can I prove this? All I have to do is look at your students. They are lazy. They would absolutely rather not be working. In fact, you have to be crazy to want to work. And Americans, as we learned this morning, are the craziest because we work the most. We don't take vacation. And we love to cheat, but this is not cheating as in you did the wrong thing by looking at his paper. We like to cheat in order to make things easier for ourselves, right? If you have to paint the fence, the best way to paint the fence is convince your friends that it's a desirable thing to do, so they will paint the fence for you. That's the ultimate essence of cheating. And it's fundamental to human nature. None of us want to work harder or longer. All of us would like someone else to do the job, and this is what animates all innovation. So, the next question is, how can you answer my annoying question? Right? What is the rank order of things? And the rank order of things is, this is my metric. So you rank them by taking the impact, or rather the absolute value of the impact, right? What I care about is not whether it is net good or net bad, but rather, is it something that affects people? And then you multiply it times the total number of people who have ever been affected. It's pretty simple. And it makes for good guesstimates. Now, the note here is, because I'm a lawyer, I always give caveats, right? There's no requirement that the people affected know how the innovation works or even about it. Right? So very few of us understand how the little tiny people get in the box and read us the weather on that thing each morning. Right? They fly through the air somehow. Very few of us understand how, when we turn the key, something goes vroom vroom, and let alone be able to fix it. But we use it, we're impacted by it. So that's how I am going to value. Now, this, of course, creates a bias. And the bias is to newer stuff, and the reason is that by most accounts, roughly 1/3 of the people who have ever lived on the planet are alive today. 1/3 of the people who have ever lived on Earth are alive right now. And you can see that from this population curve, which basically says that there were none of us pretty much until around the time of the Common Era, around the time of Jesus. And there were relatively few of us until the late 18th century. And now there are lots of us. 7.4 billion climbing to 12.5, we know that. So if you multiply times the total number of lives, the best guesstimate is that approximately 24 billion people have ever lived. So that's how you figure it out. So, I'm a lawyer, here's the disclaimer. This is my opinion. You are entitled to your own opinion. As they say, you are not entitled to your own facts. It's not right, it's not wrong, and it's intended to stimulate you to come up with your own list. And we'll give you plenty of chances to do that. What matters, as in all of what we do as teachers, is that you think about it. That's what we're going for. And so, now that I've whet your appetite, I know you can't wait. Anybody have a guess what number 25 on my list is? That's an unfair question, of course.
25 is the low one.
25 is the low one. It's the least important of the top 25. Okay, I asked that because when you all come up with reasons why I'm wrong on my list, you're going to have to kick this one out of bed, right? Because it's the top 25. It's not the top 20. You get how it works, right? Yes?
I have a question about how you're measuring impact.
Yes?
I have a question about how you measure impact in terms of time. So are you measuring it just at the time the innovation is made?
No.
Okay, so we could talk about like the wheel,
Right?
and that would have affected everybody.
Everybody since it was invented.
Okay.
Absolutely, yes. This is an ongoing cumulative process. Right? Unless, of course, the innovation turns out not to stick around. Some do, right? Some get superseded. So number 25, we're going to walk down this list pretty quickly, is relativity and quantum mechanics, attributable to our friend Albert there. And the equation that you're seeing is from the amazing year 1912, when Einstein first conceived special relativity. And the reason that this makes the list is that without these intellectual concepts of how the universe works, almost everything that we recognize as truly space-age and modern technology would not exist. Right? No semiconductors, no LEDs, no high-speed internet, none of that. In addition, we would not have come to understand the fundamental structures of matter and energy, and that means we would be missing some other important things like X-rays and CAT scans and MRIs and all sorts of technology that springs from what was a very, very short, highly technical and imaginative paper. The mathematics is fully graspable by anybody who's at the senior high school level. What was not graspable by anyone before Einstein was this thought experiment of his of being a passenger on a light beam. something that was so radical that he was ridiculed for it for 20 years until later theorists came along and devised scientific means to test the theories. There's not a single thing that Einstein said in either special or general relativity that has not been able to stand the test of experimental time. Now, Einstein, in his later years, resisted quantum mechanics, but it flowed directly from his own theories, and he simply couldn't believe that things in the world were not deterministic, because he grew up in a world of Newtonian determinism, that one billiard ball hits another and goes off in a predictable way. While in quantum mechanics, when a billiard ball hits another billiard ball, A, you don't exactly know where it's going, and B, 2 billiard balls might be the result, or maybe none, or maybe a fraction of a billiard ball. And it has taken us a very long time to accept that one. That's very strange for us humans, because we live at a different scale. Number 24 starts a theme that you will hear again and again in this talk, and that is the theme of amplifying our human abilities. Why do we innovate? We innovate because we're lazy and we cheat. And what you're seeing there on the left is the original electric motor. Think of what our city would look like if we didn't have electric motors. How tall would the buildings be? 6 stories, right? Because who wants to go to the 7th? Nobody. How tall were buildings before we invented electrically driven elevators, right? 6 or 7 stories max. Would we have buildings where the windows didn't open? No, because without electric motors, it would be impossible to have air conditioning. And without air conditioning, these buildings would be nothing but saunas. Right? Our entire world would look different. No hybrid cars, right? No CD players. Think of all the things that run on electric motors themselves. And then think about the extension of electromagnetism in the theory to simple things like, well, radio waves. Think of what the world looks like without the ability to transmit information wirelessly over distances. We take it for granted, and yet it's essential to our understanding of our world today. It amplifies our ability to communicate at a distance, and it amplifies our muscle power. 23, electronic communications and the internet. Believe it or not, I only added this to the set about 2 months ago. Why? Because finally, I came to some data that said that of the 7.3 billion people on the planet, over 5 billion of them now have access to the internet. Now, 3.5 of those 5 billion do it with a simple cell phone. The infrastructure of wired internets don't exist in most of the world, but most of the world accesses the internet nonetheless. They email, they tweet, they don't Facebook so much, but they also search and get answers and access information, all through cell phones, and not smartphones by and large, dumb phones, where you have to hit the letter 3 times to make the right one. People are doing it. People adapt. And that kind of growth, right, from a few thousand people. I'm old enough to remember the first time I logged on to Yahoo. There were 231 bookmarks in Yahoo. 231. That was it. And today, 5.2 billion users. And so that tremendous growth means that in the scope of the number of people who are being affected by this technology, it climbs the ranks. It makes it to the list. Inventor Al Gore? Yeah. Okay. Number 22 continues this theme of amplifying what we can do with our muscles, and in this case, it's a sequence of developments of steam engine power from the very first one, what you're seeing there in the diagram is the patent diagram for the very first steam engine called a steam digester. It was installed in a little boat on the River Seine in Paris, and after driving the boat a couple hundred yards, blew up, fortunately throwing the inventor into the water rather than killing him. But within a short span of 75 years, it became the Watt steam engine in England. So a French invention crosses the channel and is rapidly developed into the engine that changes the world because of the Industrial Revolution. Because the first and foremost use of the steam engine was to pump the water out of coal mines, and the most important use for the coal that you could get from a deep mine was running a steam engine. And so in a curious circular way, England all of a sudden goes from powering itself with little water mills to being completely steam powered, and it wasn't long before they mounted it on a wagon and put the wagon on rails and mounted it in a boat, even to the point where if you want to understand why our Constitution has a clause that's specific to patents in it, all you have to understand is that a few blocks from here on one sunny afternoon in July, all of the delegates to the convention that was writing the Declaration were invited down, the Constitutional Convention, were invited down to the Delaware River to witness a demonstration of a steamboat. And they recognized all of a sudden that the ability of that boat to travel upstream on the Delaware faster than the current was carrying it back down the Delaware meant that all of the riches that came from inside the country would be accessible someday, and that started them off. And in order to assure that that would get developed, they executed economic theory that they inherited from England. How did they know it? Because James Watt was able to amass enough capital to build an empire of steam engines because the British Crown gave him a patent on it. Otherwise, no one would have invested the money, because over in France, everybody was stealing the designs. And so that was the difference. Number 21. Well, if you don't have steam power, the next best thing is water power. And water power is very ancient. If you read Guns, Germs, and Steel, you will come to understand that Europe was especially blessed with lots and lots of little streams into which you could dip a water wheel and run a mill, and that created small-scale industrialization in Europe. The first type of water wheel is the one you see there. It's called an undershot water wheel. And in physics terms, it's about 28% efficient at extracting the power of flowing streams of water, which is pretty good considering that the water flows 24 hours a day, 7 days a week, for the most part. Now, 28% doesn't sound like a lot, but how efficient is your car at extracting the energy and the gasoline you pay so dearly for? Anybody know? About 28%. Okay? Now, make one simple change that came along 250 years later. Build a race that dumps the water on top of the wheel instead of dipping the wheel into the flowing water underneath, and the efficiency of this system rises to 75%. It triples. The only reason we don't run our cars this way is that giant tank of water on the roof is very ungainly. Number 20 is me cheating. Because what I've done is to combine a number of things that occurred over a fairly long span of time into one concept, what Mr. Jefferson would have called natural philosophy. The idea that the legitimate study of the world is the application of the human intellect to figuring out how things work. If you are a Renaissance man or an Enlightenment man, you tell yourself that what you're trying to do is understand the mind of God. If you are a more modern inquirer, you tell yourself you're trying to understand just how the universe works, and you do away with God, and it took a lot of philosophy to do that. But the idea that we should study nature goes back to the ancient Greeks. They were observationalists. All of the ancient science all of the ancient math is observationally based. We had to wait, however, from the time of the ancient Greeks, about 200 before the Common Era, until about 400 years ago, for a crazy Italian named Galileo to come along and tell us that rather than just observe, we should interact with the systems. We should create experiments, and we should test the theories that we had about the way things worked. That we should look for exceptions, that we should try to disprove our own knowledge. And Galileo gave us experimental science in the process. And in order to do that, you had to develop formal systems to discuss the subject. And so over a period of time, you developed the necessary mathematics to express what you were looking at. Logic and statistics and calculus and even things as simple as zero. One of the questions I ask people is, how do we know that Jesus was not born in the year 0? Anybody know? It's pretty simple. We humans didn't invent the concept of 0 until about the 7th century. Look at Roman numerals. No 0. Which leads to one of the jokes that makes my daughter groan all the time. Anybody know what this means? Yeah, it's a Roman centurion ordering 5 beers. But the idea that we have a method for knowledge acquisition and verification all of a sudden means that we are not merely repeating the knowledge of the past and taking it on faith. And so the Industrial Revolution is a result of a knowledge revolution that precedes it. In fact, we would say that the very idea that there is something called an idea springs from this period of human history. Most people in the world never bother to think about thinking. We do. If I can change the slide, it would be good. There we go. Number 19. Would not surprise you to know that in the History Channel's way of thinking, this is the most important invention in the history of the world, the printing press. And they specifically were talking about Gutenberg's press. But as I learned a few years ago, when I was on a panel with the curator of the Ancient Printing Museum in Seoul, Korea, the first movable press printing type was invented by monks in Korea. And we know this because they printed a book we still have called the Jikji. And they made copper type pieces, that's what you see arranged there, and laid them up in wooden frames and printed with them. And they did so in the 11th century. By the 12th century, no one was doing printing this way. All of the ancient Far East had gone back to woodblock printing. The question is, why? With such a radical, wonderful invention as movable type, why would anybody go back to the old way of doing it by actually carving the blocks by hand? Exactly. The answer is because they have too many characters. You see, in Chinese script, there's about 5,000 characters, and it's very easy to pick out the characters that you need and put them into the layup box. But when it comes time to clean up after yourself, remember I've told you humans are lazy, you have to pick out each one of those characters, which you are now reading in mirror image because it's a piece of type, and you have to figure out in which of 5,000 little cubby holes do I put this one. And you have to do that a lot. And it became such that we know that all they did was dump the stuff. And it became phenomenally expensive because they had to mold new characters all the time, and they had these giant stacks of characters that were all jumbled up. And so the technology died out until Gutenberg came along. Now, Gutenberg was not a printer by training. Gutenberg was what we might refer to as a Renaissance man because he knew a lot of different things. And the first problem that Gutenberg knew about was metallurgy. And what he knew is that most metals, when they solidify from a liquid state, contract. They get smaller. This is a problem because when you go to mold a piece of metal type, as it contracts, it pulls away from the mold, and you get voids, which make the letters imperfect. You get these dropouts because the metal is contracting. Now, he also knew that there were certain metals that didn't behave that way. And so what he did was make an alloy, a mixture of lead, antimony, and zinc, which we today call type metal, because it behaves very much like water in that when it freezes, it expands. It fills the mold and creates perfect characters. So that was his first one. His second one was that he had friends who made wine. And he knew that if you were going to print effectively, you needed to generate a lot of pressure to force the paper onto the type, because the type was going to be uneven. The way to solve that? Well, you see it there. He adapted a grape press and was able to take a grape press and use the press part of it to make a printing press, to put the type underneath to press down on the paper. The third problem that he had, he solved because he was a chemist. You see, if you take most ink, which is water-based, and you put it on metal type, what does the ink do? It beads up, right? Just like on the surface of your car after you wax it. Who waxes cars anymore? Never mind. So it beads up, and that also creates imperfect type. But Gutenberg had a lot of friends who were really skilled in this newfangled way of painting called oil painting, in which instead of dissolving the pigments in water, you dissolve them in oils that are derived from plants, principally linseed oil. And so he made oil-based inks that didn't bead up on the metal. You take the type metal, you take the press, you take the different ink, and you combine that with something else that Gutenberg was, and that is a master marketer. Because Gutenberg lived at a time when literacy was gaining, when education was gaining because the church had fully penetrated, and when the mark of being an educated person was owning your own Bible, the bestseller. And you take all the technologies together with a product that everybody wants to buy, and you have a hit. Now, what Gutenberg didn't have was a good system of protecting his invention, because Gutenberg forced all of his apprentices to sign non-disclosure agreements. And within 3 years of the introduction of the press, at least 2 of Gutenberg's apprentices had left Magdeburg and gone to other cities in Germany and set up their own printing shops and were printing their own Bibles and passing them off as Gutenberg's, by the way. How do we know this? Because Gutenberg spent the last 30 years of his life in litigation, and we have all the litigation records. He lost. And his loss was our gain, because shortly after Gutenberg's death, Luther came along. It became legitimate to print the Vulgate Bible, the Bible in the native language rather than Latin, and printing exploded across Europe. In fact, it exploded to such an extent that the storage of knowledge became part of the book trade rather than the librarian's trade. It became important to disseminate, not merely record your knowledge. And that trend continued. So we all owe all that to Gutenberg. 18 is fossil fuels. Now, coal is a fossil fuel that's very, very old. The oldest written records about coal talk about rocks that burn and go back to 3,000 years ago, because there were coal seams that came to the surface, and ancient people knew about them in the Middle East. But real fossil fuels didn't come about until 1859 in Ohio and western Pennsylvania, when we almost simultaneously started drilling for oil and natural gas. Think about the echoes of that into the Marcellus Shale today. But think about what our world looked like before 1859, when the best you could do was run on whale oil, and after 1859, and shortly thereafter, when cities became lit with gas lamps, when industries became run by gas turbines, and when eventually we mobilized the country on petroleum products, and then built an entire industry of synthetic chemistry on those same petroleum products. You cannot imagine what our life would look like without fossil fuels. Our cities are based on them. Think about what this city would look like were it not for the advent of the car and the truck. Right? How would we get things into a city like Manhattan? Well, it's pretty simple. There are pictures of Manhattan in the 1870s with entire railroads running right down the middle of the street, running on coal. Pretty simple. But this changed our world irrevocably, and we're still paying the price, and we're still looking for a way out. Think of the geopolitical consequences of petroleum. 17 is the specialization of labor, which my friends in the social sciences and in archaeology tell me resulted from, my famous word for the day, sexual dimorphism, otherwise known as ladies have babies. And guys seem to have better hand-eye coordination, meaning we shoot things and club things a little better, maybe run a little further and faster. And that division of labor exists in the animal kingdom, but just to the biologically mediated roles. Where we took it a step further was specialization of labor based on knowledge and skill, which is the foundation for all economies. So you have a situation where somebody does something well and someone else not so well, and you decide to exploit that difference. That's my favorite, the hunter-gatherer distinction. And that's the first one we did. Today we all specialize. A friend of mine used to tell a story about a hypothetical caveman named Og. And Og will reappear later in our story, but it turns out that Og was really good at making spear points. But he was not such a good hunter. And you can imagine how that specialization was exploited. Innovation number 16 is one that most people have told me, that one should have been obvious to me. I thought of the printing press, but I never thought about paper. Because with a printing press, if you don't have any paper, it's not worth much. And the history of paper is pretty interesting. We know that it was first developed in the ancient Near East and in China simultaneously, but that the major advances in paper were, in essence, first that we went from animal skins to paper at all, to plant fiber products. And why did we do that? Well, animal skins are expensive and difficult and smelly to produce. And they're a limited quantity, which is why we have things called palimpsests. A palimpsest is a literally hidden writing, because if you got a hold of a parchment and you didn't value what was written on it, but you wanted to write something else on it, like a hymn or a psalm or a prayer, you took a sharp blade and you scraped off the ink from the last guy, whose name was probably like Pythagoras or Aristotle. You got rid of all that ancient heathen stuff and you wrote down your new hymn. Fortunately for us, you didn't get rid of it all, and something called neutron activation analysis now allows us to read the stuff that used to be on the parchment, but there just aren't that many parchments. You had to figure out a different way to do it. And so the development of paper went through a number of stages, most of them relying on natural fibers like cotton and hemp and so forth. But the major innovation came about in the 16th century with the discovery that you could use wood pulp, that you could grind up trees and make paper out of it. Now that carried with it a cost, because the paper was tremendously cheap, but if you expose it to a little moisture and a little air, it falls apart almost overnight. Now, interestingly, if you don't expose it that way, it lasts pretty much forever. We, in fact, have dug up newspapers from landfills around London that go back 500 or 600 years, and you can read the paper as if it were printed this morning. But you'd better do it in a glove box filled with nitrogen, because in 20 minutes it's going to be so much dust. So the anaerobic environment of the landfill keeps it nice and white and pliable, but boy, it gets eaten by oxygen as soon as it's out. So paper is an important thing. Paper is what created the exchange of knowledge that really was one of the fundamental breakthroughs of the modern age. Number 15, this is the prototypical patent attorney idea. Right? Not a bad idea, but no quit day job. We don't understand exactly what the history of the wheel is. That's shrouded in the mists of time. This is the way we think it may have come about based on some of the evidence. So sometime around 5,000 to 6,000 years ago, somebody discovered that you could move heavy things by reducing friction by rolling. First on a roller, then they used a sledge, which has an ability to move linearly with less friction. Then you put the sledge on the roller. Eventually the sledge cuts some grooves. That becomes an axle. That becomes a wheel. Next thing you know, it's a Harley Davidson. Pretty cool. Now, this also created an interesting worldview that without a wheel, ancient peoples couldn't have done anything. So for a long time, we didn't understand things like how the Egyptians built the pyramids, no evidence of wheels there, or how the Moai were moved on Easter Island, which is a mystery that was solved just 18 months ago. It turns out they took these 45-foot tall, multiple tens of ton stone statues and made them walk. It's a fascinating documentary. Look for it online. Being a lawyer, you would expect that for me, number 14 is law. Formal law codes. The earliest one that we have written down is the Code of Hammurabi. You all know that one as an eye for an eye, a tooth for a tooth. But hey, it was an improvement on because I say so. The Book of the Dead is a contemporary of that. The Ten Commandments came about 1,000 years later, and the Roman 12 tables came about 500 years after that. Law is a mechanism for economic predictability. That's all it is. We have laws so that we can foster economic relationships without having to renegotiate everything all the time for every transaction. The next time somebody tells you that free market mechanisms are the best way to do everything, propose to that person that at the next time you drive up to a four-way stop sign, everyone should get out of the car, walk to the middle of the intersection, and negotiate for the right to go first. You see, free markets don't always provide the most efficient solution. Sometimes you need convention. Don't believe me about these laws? Think about the 10 Commandments. If you were writing down the 10 most vital moral strictures in the world, would coveting your neighbor's ass be one of them? No, that's an economic condition. Don't believe me? Read all the rest of Leviticus. Almost all of it is economic in nature. These were people who were trying to make sure that you could efficiently run a society which was largely illiterate, with some rules that everybody could depend upon because they were being enforced by the people who had some power. That's what law is. The first day I got to law school, my professor in my first class put it very simply. He said, "Welcome to law school. As a lawyer, your job is to keep your client from shooting the other guy's client at high noon in the middle of the street. Everything else about law is window dressing." Literally is. It is, remember I talked about time and dispute resolution? More sophisticated economies invest more in dispute resolution mechanisms. That's why we build big buildings with columns and we put people in robes and so forth. But fundamentally, we're supposed to keep people from resorting to violence. That's what these are all about. Number 13, money. It may make the world go round, but it took a long time to figure out. This is the way we think it came about. You see, you didn't need money when you were itinerant, migrant, a hunter-gatherer. You did mostly bartering. You needed money when you accumulated surpluses. And once you could accumulate a surplus, you needed something that said to somebody, I own something. And that something that I own is value. And so what we believe happened is that in ancient Sumerian city-states, the landowners would collect their harvests and store them in giant jars, giant clay jars. Why clay jars? Well, they're good for keeping the rats from eating your grain. They're good for keeping your grain dry. That's another story. But once you have all these jars hanging around, you have a need to be able to exchange them, so you store them in a warehouse. And you don't necessarily own the warehouse, so the guy who owns the warehouse has to give you some evidence that you've deposited a jar full of grain, and the easiest way to do that is to give you this little tiny replica of a clay jar called a counter. So you deposit your jars, and pretty soon your ancient typical Sumerian landowner is running around with a bulging pocket full of little tiny clay jars, each one representing a jar in the warehouse. And he could meet the merchant in the marketplace and he could say, yes, I would like that goat, and I will give you a jar for it, and he could just hand them the little jar. But people got tired of all the jangling jars, so they came up with a really neat idea. Let's make a little envelope out of clay, and let's put a number of jars, little tiny jars, inside it and seal it up and bake it in the sun, but before we do, we'll write the number of jars on the outside. Cool. And when it was all dry, you could shake it and hear the jars inside, and if you needed to make change, well, all you had to do was slam it on the table, break it open, and you could make change. But after a while, that got to be tedious too, so we eliminated all the little jars inside that you could hear shaking, and we trusted the number written on the outside. Trust. That was the beginning. Because from that point forward, what we trusted was the money. And whether we used coins that were made out of specie, where the value was in the metal itself, or later on other types of representations of value, this facilitated exchange. We learned the problem with specie pretty early on. Who knows what a piece of 8 is? How's your pirate lore? Right? What's a piece of 8? That's right. It's 1/8 of a doubloon. Right? Because how are you going to make change from a doubloon? Well, it's silver. It's pretty easy. You take your knife out of your pocket and you cut it up. It's soft metal. You cut it into 8 pieces. Great. So now I know what a piece of 8 is. What's one of the ways in which you could be cheated in Shakespeare's time? What's one of the greatest insults that Shakespeare could level at you? He could say you were a shaver. What is a shaver? It's someone who will make change, but before he does, he'll take his knife out and nick a little piece of silver off the edge of the coin and put it in his pocket. He'll shortchange you on that. That's why your coins have ridges. That's why ruffles have, no, sorry. The Chinese invented paper money first because the Chinese also invented government bureaucracies first. And the government bureaucracy was ubiquitous, and it could tell us what was going on in the world and what to think. But then we came up with this idea of fiat and credit currency, which is the idea that if there is a network of trust, I can give you money on the theory that you have a cousin over there, and once I've given you the money, your cousin will make good on the piece of paper that says you have the money, and this is the equivalent of a wire network for international banking. The Dutch invented this one. Today, we have currency called fiat currency. Many of the students that you have think that there's gold in Fort Knox. There isn't, and hasn't been for a long time. The reason that our money has value is that people in the world trust our political system. Because our political stability and the power of our economy are the guarantor of the value represented on that piece of paper. It's been a very long time since we had things like silver certificates, where you could actually go to the government and say, give me the silver, give me the specie that backs this. We've been off the gold standard for a very long time. What people trust, the reason people use dollars, the reason that the entire underworld of the world uses US $100 bills as its medium of exchange, the reason that people will buy our treasury bills at negative interest today is more a matter of where else are you going to put your money that's safe? What other country is not going to undergo a revolution, a nationalization, a devaluation? The great hope for the euro was that the euro would compete with the dollar as a medium of exchange internationally. Oops. Number 12 is one of my all-time favorites. I don't care where you stand on this one, but the invention of the institution of religion is one of the great genius acts of all time. Why? Because it is a social institution which promotes efficiency and organization. And I don't care which religion you're talking about, whether it's religions of the ancient Sumerian city-state or the Greek and Roman gods, doesn't bother me, because religion promotes social cohesion. It forms in-groups and out-groups, and that motivates people. Being a part of an in-group makes you do things you might not otherwise want to do because you're inherently lazy. And being a member of the out-group may make you strive a little harder on the other side. It gives the priestly class, whatever that is, super authority. It's no longer because I said so, it's because the big guy said so. And that motivates people in a certain way. It shapes behavior both prescriptively, because we get to say thou shalt and thou shalt not, but also motivationally, because the people who built the great Cathedral of Notre Dame were supported by an entire community over 3 generations of artisans and paid barely a living wage for the same reason, they were motivated for the same reason that someone walks into a crowded market in the Middle East and blows himself up. The promise of a reward in the afterlife. And regardless of what you think, as an economic incentive, this one's a genius move. Because you, as the guy in power, gets to promise something, take out a loan, that you will never have to pay off. And this creates societal organizations that are tremendously effective. All you have to do is look at the great things that have been accomplished and the not so great things. Remember I said I value the absolute value of impact. So for every great cathedral, there's a children's crusade. Number 11. This is the first one that really allows us to talk about information technologies. We'll see how important this stuff is. You develop systems of writing, and our systems of writing have gone from the pictorial, both Chinese and cuneiform, and I understand the one on the top left of the cuneiform, I understand that's a bird. I will never understand the late cuneiform, the top right, being a bird. I'm sorry, I'm just cuneiform blind. But then something amazing happens. And that amazing thing is that we go from these pictures of concepts and we abstract them to something completely different, an alphabetic script, a phonetic encoding of information. And what you're seeing here is the evolution from ancient Phoenician to our modern system of script in the Roman world, which tells you where certain letters came from and where they ended up, which is pretty cool in itself. But the idea that we use these few characters to encode the sounds that make the words that represent the concepts is radical. In fact, it's this invention that allowed Gutenberg fundamentally to succeed. Because you see, instead of having 5,000 characters to put away, Gutenberg had only 2 times 26 plus a few punctuation marks. And in fact, the 2 came from the fact that he had both small letters and large letters. Now, if you've ever done any conventional old-style printing, and I don't know how many of you ever have, I had to in junior high and shop class, when you print, you have boxes of type. And the boxes of type have little cubby holes in them, and the size of the cubby hole is sized based on the relative frequency of the letter in your particular language. So for an English script, the box with the E is the biggest because it's the most frequent letter. And you have all of the little letters when you print laid out for you in a box that's here, and a printer's station then has a shelf up here, and there's another box up here that contains all the capital letters. And that's where we get the terminology lowercase and uppercase. It comes from printing. Now, we substituted for all of that, or almost all of it, a different form of printing at the end of the 19th century called hot lead or linotype, which controlled all of our information processing well into the 1980s. But that's really the innovation that allowed the printing press to take off. We're into the top 10, with all apologies to David Letterman. Food preservation. Your students believe that the food preservation technology is a large rectangular box sitting in the corner of the kitchen. Food preservation clearly goes back a lot before this. Why is it important? Well, if you can't preserve your food, you have to dig up or kill your dinner every single day. That means you can only go places with reliable food sources. That means if the food source becomes unreliable, you are moving. In other words, it provides quite a constraint on you. But if you can preserve food through whatever method, and we developed a lot of them over time, all of a sudden you get portable, and all of a sudden you can survive lean times, which means your geographic range expands dramatically. Right? Now you can live in places where you can produce a lot of food in the spring and summer and fall and survive the winter. It means you can move out of temperate zones in Africa and spread across the globe and make use of other forms of natural resources. So food preservation is key to our success as a species. Number 9. This is another cheat of mine because it's a long historical process, but metallurgy. Because, hey, you can only dig with your fingernails so far. And that's literally what this is about. If you can develop things that are harder than natural substances, then you can really succeed in the world. And doing so requires some other innovations, but we'll talk about those later. We developed metals in this way because this is the order of the temperatures and the hardnesses of the technology required. So the soft metals, copper, gold, and bronze, easy to dig up. You don't have to heat them very hot to melt them. You can do things with them. You can also hammer them because they're malleable, formable. Add some tin to your copper and you get bronze, which while not malleable is much harder than copper. So it's more durable as a tool. Iron has to be heated much hotter, but it's also much harder. And you can do more work with it. Particularly, you can do work in the ground. And finally, steel. Jared Diamond knew what he was talking about. And so, major advances in metallurgy, both artistic and in terms of weaponry. Early Iron Age daggers, these are actually being molded and then forged. So they're actually poured into stone molds. Number 8, pottery and ceramics. For a couple of reasons. One, if you can cook your food, you digest more of it and you gain more nutrients. Recent books point to the difference between us and the great apes. With all due apologies to my physique, gorillas have really large bellies. And that's because they don't cook or process their food. They need to have big guts so that all the microbes can chew on all the plant matter. And they have to eat a lot of stuff every day to get a little bit of nutrition. We came along and figured out first that we could process by pounding our food in order to release some of the nutrients and later on cook it, which destroys some of the tough chemical bonds and makes those nutrients available to us. And the best we can figure out from the available evidence, it was cooking that allowed us to get big brains, because your brain consumes more than 20% of the energy of your entire body. Having something to cook in is very useful, but having something to store your food in is also useful, because that way the vermin don't get it, you get it all. So your effort is worthwhile. And that's one of the oldest intact clay pots that we have from about 10,000 years ago. Number 7. This is another composite innovation, farming. Because if you are a hunter-gatherer and you're not farming, you live on what you can find, you have a large range, you're not being intensive, you're also not developing a lot of very, very high-quality calories. But farming allowed us to do that, starting with the domestication of animals, then plants, then hydraulic, which is irrigation, the development of the plow. And this is one place where one of my audience members, I spoke to a Mensa group in New Jersey 2 years ago, and a 15-year-old looked at this thing and said, "You're missing the seed drill." I put it in. He was right. Crop rotation is relatively new. This is true rotation, not merely leaving a field fallow. That is much older. Chemical fertilizers are really new, 17th century. The nitrate fertilizer, exactly 100 years old this year. The Green Revolution, the idea that we could exceed the Malthusian trap, comes about in the 1960s. And for good or bad, GMO crops, which allow us to produce a tremendous amount of food without losing it to pests or fungi, 1980s. We're just dealing with the legal and health ramification possibilities of that. The domestication of animals proceeds along this line. The dog at 15,000. I asked a doctor friend who teaches at Hahnemann what the first domesticated animal was. He said it was the E. coli that lives in your gut. I told him, yeah, but they don't fetch. Then the sheep, the goat, the pig, the cow, the chicken, and last the horse. I thought the horse was much earlier until I started looking at this. But the horse comes late in the game. But all of these are domestic animals tuned for us to our will because we selectively breed them. Now, by the way, if you're against genetically modified crops, literally nothing you can buy in the grocery store is not a genetically modified food. You would not want to eat ancestral corn called teosinte. It's pretty much inedible. If you don't boil it for about 3 hours, it's poisonous. Ancestral tomatoes, they're a member of the nightshade family, folks. They're poisonous. Potatoes, the stuff you think of as heirloom potatoes, the little orange and purple ones, well, think of ones that are like the size of a pea and contain a lot of sand and grit. That's what a potato was before we started modifying it. Chickens, you wouldn't want to eat an ancestral chicken, let me tell you. No breast meat, among other things, and long skinny legs that are full of tendons. And so it is with each crop. Anything you can buy has been genetically modified. The difference is it hasn't been gene spliced. And by the way, all those cute little breeds of dogs you see at the Westminster Kennel Club competition on TV, they've existed only for 350 years. More than 350 years ago, dog was a mutt with a ringtail, period. And all of those variations, big, small, fat, ugly, cute, whatever, fuzzy, they're all less than 350 years old and all due to our intervention and breeding. So the next time you see a wiener dog, think, gee, my ancestors were brilliant genetic engineers. Domestication of plants proceeded along the same line. The big surprise for me here is the first domesticated plant. It's called the bottle gourd. Anybody know why? Because if you can't carry a canteen, you can't go very far when you hunt. So the first domesticated plant is a gourd with a long neck, a squash, that you can dry and cut the top off and string around your waist and use it to carry water and that increases your range over which you can hunt and gather. From there, all of the crops proceed in exact order of production of calories per acre. So the later crop produces more usable calories per acre, which explains why rice is the most cultivated crop in the world, because it's the most efficient in terms of use of land for supporting populations. Number 6, clothing. If you don't have clothes, you don't go very far. It's pretty simple. You either overheat or you freeze to death. We know that clothing is very old, but clothing is organic and it decays, and we don't know very much about its history. Indirectly, we have seen that there are sewing needles, principally made out of bone, that are quite old, and we know that the earliest cloth is around 5,000 to 6,000 years old. We think we know what typical Stone Age dress looked like, and that's pretty simple. There it is. Oh, I'm sorry. No, typical Stone Age dress was more like that. Okay, you are what you eat, and you wear what you eat. And so skin clothing was the norm a long time ago. But by a little bit later, we got better at this. There we go. I'm sorry. There we go. That's Ötzi. Ötzi was unearthed at the top of an Austrian glacier about 15 years ago. That's what he looked like. He was wearing a matted woven grass cape. He was wearing snowshoes with insulating grass in the bottom. He was carrying leather pouches with various medicinal herbs as well as his weapon. We know that Ötzi died of an infection that resulted from somebody shooting him with an arrow in the shoulder. And he was perfectly frozen and preserved up there at the top of the glacier. He's in an Austrian research laboratory museum today, and we've actually taken the contents out of his stomach. We know what he ate. We know what parasites he had. We know a lot about Ötzi. He was a man of fashion, and that's what he looked like. And he needed it because his range was in the little ice age of that period, when the temperatures at the top of the mountains that he was climbing would have been below 0 Fahrenheit. And yet, he didn't have any North Face jacket. So that's Ötzi. Number 5, back to information processing, the concept of symbolic communication. That's a cave painting from Lascaux in France, in the Dordogne, and there are lots of others. We know that it's about 32,000 before the Common Era, and again, there we go, that's cuneiform. We have hundreds of thousands of these little clay tablets. Almost all of them are accounting records, so the next time you meet a CPA, thank them. Don't diss them, because what we know about this economy comes from these records. They're baked in the sun, and they'll stand up to just about anything, and when you have a fire in your city, they actually survive better. They get harder. So we have lots of these things. These were the later version of those little clay envelopes that I talked about as being the first money. Number 4, we're really down to the important stuff here. The lever as a simple machine. For those of you who teach science or study physics, this is your time to shine in the sun, because the lever shows up in a lot of different places as plows. We talked about that for agriculture. Hammers, paddles, bows, and my favorite, the thing illustrated there, a spear thrower known as an atlatl, which is just so much fun to say. I say it all the time. The quote at the bottom tells us all we need to know. Give me a place to stand and with a lever, and I will move the entire world. So that kind of tool allows us to do so much more with our muscle power and our weight that it allows us to cheat. Number 3, the inclined plane, another simple machine from physics. This one shows up in a lot of places, and what you're looking at there are some of the oldest human-made tools in existence. 1.9 million years old. They're just sharp rocks. But believe it or not, all blades, knives, wedges, screws, chutes, ramps, slides, they're all inclined planes. What do they allow you to do? They allow you to trade distance for work. You can't lift the stuff directly up 10 feet, but if you're willing to push it up a ramp 20 feet, hey, it's easy. Don't believe me? Look at the Americans for Disabilities Act and all the wheelchair ramps that are around. Don't believe me? Try driving in a nail rather than driving in a screw, and look at how much effort it takes. Don't believe me? Take a look at these inclined planes. On the left, the Archimedean screw, the earliest form of irrigation pump known to man. All you do is dip one end in the canal, use the other end where it comes out, turn the screw, and it pumps the water up into an irrigation ditch in your field. On the right, a Clovis point, the most efficient arrow and spear point ever invented. Number two, somebody said it earlier, fire. In this case, taming of fire. So the first thing you need to do is know that there was fire around. It came from two places, lightning and volcanoes, neither of which is extremely dependable. So if you want some fire, you'd better figure out some things fast. If you ever watch Man vs. Wild or Bear Grylls or any of those programs, you know that one of the first things you need is a fire because it keeps you warm, because you're a warm-blooded animal, and because it scares away the beasties. Secondarily, you can use it to cook whatever food you catch. And so, if you can find some fire, your first job is to preserve it and be able to carry it around. And in order to do that, you use something called a cigar or a smudge bundle. You bundle up some grass and weeds and dry things, and you light it so that it smolders, and you cover it, and then when you need some fire, all you do is take the cover off and blow on it. I get fire. But more than that, the guy who becomes a good Boy Scout wins. So fire starting technologies are critically important, and in order to do that, the earliest ones are the fire plow, in which you rub a stick in a groove, and the fire drill, somewhat more complicated, where you twist a pointed stick in a hole, both to generate enough friction so that you get fire. The old Boy Scout trick of flint and steel is barely 1,000 years old. Why? Because we didn't develop steel until pretty recently. And so the idea of being able to create fire on demand is one of those fundamental, central ideas, and we just don't know when we did it, but we know that we did it fairly early on because we have evidence of fire pits in caves that go back at least 30,000 years. And, drum roll please, number one, spoken true language. Other animals click, tweet, stamp, bellow, yowl, bark, but they don't have structured language. What's the genius of structured language? Well, it's the genius that allows me to have an idea up here in my cranium, allows me to flap my gums and create at least a similar idea inside all of your heads. That's really genius. Because now I can tell you my good ideas and you can answer back. And that whole way of doing things, we believe, resulted from one mutation about 100,000 years ago of a gene called FOXP. No other animal has it in the same way. But it is that which allowed us to create a whole area of our brain which does nothing but process this syntax of language. Linguists have tried to figure out what's inherent about that, and the closest they've been able to come is that that gene gave us not only the physical ability to speak, but the ability to think by analogy. that is the central important skill of language, the ability to create and hold an analogy. So there you have the top 25. It's intended to be pretty broad and open-ended, but there's a surprise. You see, one of the things I didn't tell you is that I'm a computer hacker. And computer people don't start counting at 1. We all start counting at 0. So I have for you a 0th innovation. And the 0th innovation, if I can get the battery to work, come on, last but not least, is intentional pedagogy. It's the act of teaching. We're number 1. We are indeed number 1. Why is that? Well, it is because not only do we teach, but we teach the offspring of people who aren't related to us. Think about that for a minute. What we do is transmit accumulated knowledge, knowledge that depends on our ability to formulate it in language, to store it externally to our own heads, to recapitulate it. In other words, all of this is directed to the idea that we don't have to start at 0 like every other animal on the planet. Right? Your puppy has to learn what a puppy has to learn. Your students get the full benefit of being able to sit down and read a book, listen to audio, watch video, hear you lecture, and learn everything that's important in the last 100,000 years of all the people who have come before. And we do it in better and better ways. An African griot can recite 700 generations of tribal lineage. We can teach 700 generations of bacterial change in a minute. We have the ability to allow our students to stand literally as Newton said, because he copied the statement from Charles of Chartres, to stand on the shoulders of giants in order to see farther. And that's really the genius, because we teach our young. That's the most important innovation. That's the one that allows us to get ahead and stay ahead. So if somebody talks about cutting education budgets, tell them that that's the very foundation of everything that makes us human. And stay the hell off. So people always say to me, oh, okay, I made a suggestion. How come it didn't make the list? Well, here's some of the things that didn't make the list. Right. Doctors gave me theories of disease. Building guys gave me air conditioning. People said flight, sanitary sewers, public water systems, the internal combustion engine, guns and gunpowder, plastics, WD-40 and duct tape. That's the ultimate toolbox, right? Everybody knows that? Okay. Systems of knowledge organization, calendars and clocks and almanacs, things like the atomic bomb and the concept of free will and the thermos bottle, right? Keeps hot things hot and cold things cold. How does it know? The mirror is one that was suggested, and one of my favorites, the idea that there is such a thing as an idea. All of these things didn't make the list because in my calculus, that impact versus population didn't add up when I did the numbers as closely as I could. And some of these are just quantitative, I freely admit it. That's what didn't make the list. Now, there's one more thing.
In 2,000 years, the greatest thing mankind ever devised, that I think, in my humble opinion, is saran wrap. You can put a sandwich in it, you can look through it, you can touch it, you can put it over your face and pull around and everything. It's so good and cute, you can wrap it up.
You equate this
I love it. You can put 3 olives in it and put a little one. You can put 10 sandwiches in and make a picture in it. Whatever you want, it clings and it sticks.
You equate this with
You can look right through it.
You equate this with man's discovery of space?
That was good.
And so, the question that I am then asked is, if innovation is always so great, why don't we like it more? The answer most people give is that change is hard. But back in 1796, Abraham Edelkrantz, who had the title Royal Telegrapher to the King of Sweden, wrote in a book, this one. And as a patent attorney, I will tell you that this rings truer than ever today, and I have reason to believe that it is an expression of fundamental human nature. That although we benefit from the stuff that innovators give us, we as people always treat innovators exactly as our bodies treat bacteria. Identify, attack, encapsulate, kill, and eject. Being a change agent is the hardest thing you can choose to be. My challenge to you is to be one. We're going to take a 10-minute break.